Hello, hello. Hi, everyone. Can you hear me?
Yes, sir.
Hello, hi,
Yes, sir.
hi, hi. How are you? How have you all been? It's almost been a month since we last met.
Yes, sir.
Yeah. So, how is your preparation going? Good.
Good, sir.
Uh, Okay. So, yeah. So today is like one extended tutorial session. My plan is simple. I try to do solve a very simple classification problem using Python. We'll do all those data analysis, data identification, and stuff like that. Unless you have something better that you want me to discuss, then I'm open to that. But that's what my agenda is for today. Before we begin, I can take some questions if you have any.
Sir, I have a question on get dummies.
You have a question? Huh?
Get dummies. Get dummies drop cost
Okay.
equal to 2.
Okay. Okay. Yeah. Yeah. What's the question? What is get dummies? Sorry, what's the question? What is get dummies, right? Hello, can you hear me? Oh, okay, maybe while she reconnects, anyone has any more questions? Any other question?
So,
Yeah.
so I actually completed this course in the last sem.
Mm-hmm.
So I got to become top 5% toppers. So I wanted to know about the internship opportunities under this course if it's gonna be there.
Under this course, or do you want to explore industrial internships with the help of this course? Right?
Yeah, with the help, like there is something that NPTEL toppers get the opportunity.
Okay. So it depends on what your background is at. I'm not very sure what this NPTEL Toppers program is, unfortunately, but
Okay,
yeah,
sir.
let me know what your background is and what are you exactly looking for.
So my background is artificial intelligence and data science. Currently, I'm in second year of
Okay. Okay.
engineering.
Okay. Okay. Yes, are you ready with your question? What
Yes,
do you want to know about get dummies?
yes, I'm giving it in the drop cost. So, is there any internship program also for the people who are doing very good in the exam?
I'm not aware of it. Maybe you ask the last person who, maybe she can tell you more.
And sir, when will we get our admit cards for the exam? Because I have submitted all the assignments
I
and I
think
have
they
given the exam
mentioned,
fee also.
yeah, I think it's mentioned, right? March 15th or 20th, some around somewhere that time.
Okay.
Yeah.
So this is the command line
Yeah.
where I'm being confused about the
Okay.
output
Okay.
that is produced. The first
Okay.
drop I couldn't understand. I even googled it. I didn't understand.
Oh, you want to understand what is get dummies, right?
What is get dummies and what is first drop equal to true? Well, it's based on that first drop that it is doing the get dummies program, right? So what is
Just
that?
a sec.
Because no particular column name is mentioned. This is the program income.csv that is given by
Mm-hmm.
NPTEL.
Got it. Got it. Uh, Let me see if that is something that I have in my. Uh,
Yeah, yeah, it is given. This
yeah.
KML programming, that one.
No, I mean to say, let me see if whatever I had prepared is it there in what so that we can discuss as we go with the class. I'm just checking.
Yeah, I
Mm,
can give you the output, whatever is shown by copy paste.
okay, give me 1 second. Get dummies, right? So get
True
dummies, you
and
understand, right?
false will
It's
come, no? The true and false it is coming.
so get dummies, you know, right? It is for you want to if you have, let's say, a categorical data, you want to basically convert it into some binary representation or a one hot encoding, right?
It's not going.
So do you understand what is categorical data?
Yes, sir.
What is categorical data? Anyone? Can you tell me what is categorical data?
It is the data will have many options. I mean,
Yes,
can
and
be.
and those options cannot necessarily.
Uh, Sorry, cannot hear you.
Can others hear me?
So can you repeat? We could not hear you.
Hello? Can you guys hear me?
Yeah,
Yes,
Yes.
now
sir.
we can. So can
Is
you?
my voice clear?
Yeah,
Yes, yes.
now can you
Yes,
repeat
sir.
what you said?
Yeah. So you guys understand what is categorical data, right?
Yes.
Can anyone explain to me what is categorical in very simple terms and why dealing with categorical is not very trivial?
Categorical disease, the for a particular column, the data can be entered into different type of data types
What do you
of the
mean by that?
same data type, like different categories of the data type. Like it can be like married, that's married, marital status can be married, never married,
Okay.
divorced,
Okay.
like that,
Okay.
single.
So what is the problem if I simply say कि married is zero and not married is one, something like that? Very simple representation. Why do I need a one hot encoding?
Um, if we
Anyone?
use like 0, 1, 2, then it will be useful for us to give the commands, but again we have to show it to the viewers, what is output for this particular categorical value, so we have to
Hmm.
need the string value as well.
Okay. One person has raised his hand. You want to ask? You want to say something? Saran, you want to say something? No? Hello? No? Ah,
Nothing, sir. Nothing, sir.
okay. Good, good. Yeah, so where was I? We were saying that if we have, let's say, two data types, let's say married, never married, or let's say if you have apples
Not
and oranges as two classes, you can simply say apple is zero and orange is one, and you can go ahead with that, right? What is the problem in that? You were saying something?
now the problem, I don't understand the output of this program, this KNN income CSV SAM total, that
Okay.
program that is given by the portal,
Mm-hmm.
where it is showing that new data equals to pt dot get dummies, get
Mm-hmm.
underscore dummies data
Mm-hmm.
2,
You want
comma
to understand drop
drop
first?
first equals to 3 true, drop first
Uh,
also I don't understand.
okay. So here, if I go to their actual documentation, it says that drop first is default false. So it basically is a Boolean which says whether you want to get k minus one dummies out of k categorical levels by removing the first level. Understood? No?
Sorry, I couldn't
So,
understand. A
uh,
categorical dummies.
so if you have k categorical data, you want to represent it by means of a vector, right? So if
uh,
you have three categories, you are creating a vector of length three.
uh,
Okay, and if you want to choose the first variable, so your vector should look like 100. If you are choosing the second type of category, it should look like 010 and so on.
mm,
So here, whatever I am reading from the pandas documentation is that whether you want to get k minus one dummies out of k categorical levels by removing the first level. So they are saying something like you drop the first uh, value altogether. I don't really understand what it means, but that's what they say in here.
mhm.
Okay,
Drop first
let's
means dropping the first record
dropping the first
category.
category.
Oh,
If you have k categories, you drop the first category. Okay. Harish has written something. Categorical data represents variables that can take limited fixed values. Okay, okay, got it. Yeah. Okay, good. Uh, cool. So something similar we have also planned today. I plan to look at classification data. Yes, Asit, you want to say something?
So, yes, sir. So for this NPTEL exam that will be held on 23rd, I think,
22.
that, okay.
It is on
So
22.
that exam will have similar questions regarding what was taught in the program, or will it be completely different?
What do you mean by completely different? So you have whatever you did in your weekly assignments and the quizzes, the four assignments. It will be similar. You will have multiple choice or multiple select or even some
Yeah.
fill in the blank type of questions, but it will be a level higher than what you have been doing in your assignment.
Okay. And
One level
so,
higher.
we won't be given like on the spot coding tasks. Like
No,
we'll
no,
just be have
no,
to. Okay.
no coding. But related to code, you will get some small code block and then you will be asked questions on that. Something like that would be there, but you won't have to code on the spot. Just the logic check they'll do.
And sir, one last doubt.
Hmm.
For the exam, do we only need to work, not work, but go through this NPTEL course that it will be enough, or we need to even do other studies, like go out of ourselves and like go on YouTube and do other?
I think it's better to explore because Python is a huge subject. Right?
Yes, sir.
So the KNN classification and mm, other classification and regression, all these models that is included in week 4. Hello, can you hear me?
Sir, you're not audible.
Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Sorry, I missed the last part. You guys were saying something.
Sir, this KNN classification, regression, and all these models that is
Yeah.
we are included in the week 4, all these will come in the exam.
Yeah.
Yeah.
Those are part of the syllabus.
Okay.
Okay. Any more questions?
So can you just brief us on what exactly what uh, what are the models doing on the data? Like the regression one, we understand is that it is just giving the output of the y value, which is a
Mhm.
constant continuous value. But
Mhm.
other there are the other classification as well, like the KNN one, the tree structure.
Okay. You want basically random
Exactly
forest tree
what they
and
are doing. Just
so that,
seeing whether the data is one group or not. That is the only thing they're doing. You can explain.
no, so it will take some time. Okay, this is
Okay.
a whole course in itself. This comes under the
Yes.
course of machine learning. So I
Yeah.
won't be able to unfortunately cover everything in
Yeah.
detail. You will have a lot more questions. So just understand that those are different models to classify for now for the
So
purpose of
which
this
are
course.
the models that will be coming? The KNN will be coming, and the logistic regression will come,
No,
and
no, no,
regression.
no.
These
You
three,
won't.
the programs are giving only on these three models. Three
You will only
programs.
get logistic regression and linear regression. That's it. Not on KNN. You might get few questions based on like simple questions, but nothing too detailed on it.
Okay.
Okay.
So mainly
Can you?
logistic regression and regression,
Yeah. Yes.
and KNN classification may also come.
Not necessarily.
Okay.
Okay. Can you tell us some important topics to focus on? Please refer to the uh, group homepage. Those are all the topics that are there are the important topics. It's anyway a 4 week course. There's not much topic in here. Yes. Yes, go ahead.
Yes, sir. Sir, one more doubt. Like there is still almost one more week left for the
Mm.
exam. So if we have more doubts
Mm-hmm.
by the end,
Mm-hmm.
will you consider taking one more live lecture, or will you have like will we have to personally send the doubts?
I think you'll have to personally send. There won't be any more live classes after this.
Okay, sir.
As per me,
Sir,
maybe the
how
other
we
TA
can
will take.
join the group?
Which group? Hello?
The doubt
Which group are
group,
you?
sir, where we
Uh,
can ask the doubts.
you can email me personally, or you have those Python for data science Q&A section, right? You can just post there.
Okay, sir. Okay.
Okay,
Okay.
sir. Thank you, sir.
Okay. Great. So for today's class, we'll try to look at a simple classification problem. We are looking at a simple data set known as iris data set. Is anyone aware of what is the iris data
Hmm.
set? Has anyone seen this before?
Flower. Say what a flower.
It's a very simple data set. Okay, you have three classes of flowers and you have some information. Okay, there are usually four information. You have the petal length, petal width, you have the sepal length and sepal width. This is usually a very beginner level classification task, and the set is extremely clean. Okay, you won't have any conflicting values, and the separation is also very clear. Okay, so we'll try to go slow, step by step, and understand how this logistic regression works. Okay. Now, don't ask me what goes behind on how logistic regression works. For the purpose of this course, we are not bothered about how the underlying backpropagation is happening. Okay, or how the loss function is behaving. That is that all comes under the course of machine learning, and it will take a lot of time to explain in detail what each thing does. So we'll just quickly understand. So first step is we will have to know the data. Okay. So what I've done here is I have taken this iris data set. You can just Google the iris data set. You will find the CSV file very easily. Anyway, I'll share this codes with you. So you import all the necessary libraries. Okay, so I have written all the libraries that you need. Maybe you don't need all these stuff like Gaussian, MLP, decision tree. Those
Decision.
we won't look at it for this course. But yeah, maybe you try to import these libraries first. Just simple code. No one until now, and then you load the data set. Okay, so you have a data set called iris.csv, which I loaded into a variable called df. So df is my data frame that I'm looking at. And if I look at the first five rows, then it looks something like this. You have ID, you have sepal length in centimeters, you have sepal width, you have petal length, you have petal width, and you have the species. Okay, so there are three species. One is Iris setosa. There are two other species. I'm not sure. Maybe we'll look at it later. So it's a very small data set. You have six columns and you have 150 rows. Okay, you have 150 data sets and you have six columns. 1, 2, 3, 4, 5, 6. Right? But I guess the first column is not useful to us. Okay, so we can drop that first column. Right? All good. So if I just let me run these codes right as we go on. Right. So if I just click on df.info, you get all the information. The first column is ID. You have 150 data. Uh, those are of data type int64. These are all others are float64. And the final one is object. This is a categorical data, right? And then what we are doing is you are creating you're trying to look at how many data sets are duplicate. What do you mean by duplicate? So I want to check how many rows are duplicate. I want to remove all those duplicate values. So this command called dot duplicated checks how many duplicate datas are present. And like I said, it's a very clean data set. So there are no duplicate data. Then we check how many missing values are there. So fortunately for us, we don't have to bother about filling all the missing values in this. And what do we know? What do we know about this data set? We know that this data set consists of the length and width measurement of the sepal and the petal for different species in centimeters, right? There are 150 rows, 6 columns provided. There exist no duplicate values, and there exists no null values. Okay, so data is very clear. The data is very clean. We can proceed to the next step. Right? Any questions?
Hmm.
Okay, I'm just trying to run through the steps involved in a typical data science project. Right, that's what you will be dealing with later, right? As you beyond this course. So first, you want to understand how the data set is. Now we know that the data that we have is pretty clean. Now we want to understand the variables. Okay, so if I just uh, print df.columns, I have these six indices. One is ID, sepal length, sepal width, all those stuff we know, and then we just describe those data. So this is how it looks, right? So this is a description. So you have count, you have 150 elements of each, 150 elements in each column. Then you have some NaN values in unique, top, rec, and all those stuff. Like I said, there are no missing values, but there are NaN values, right? NaN values are not missing values, right? Then you have the mean. You calculate the mean. You have the standard deviation. You have the minimum, the top 25 percentile, 50th percentile, 75th percentile, and so on. This is the entire data that you have. Okay. Now we are looking at the number of unique values for each variable. So now question is this unique values? So as I say that the sepal length in centimeter has 35 unique values for centimeter over the entire 150
Yes.
data. So it has only 35 unique entries. Okay, similar for sepal width, similar for petal centimeter, petal length, and petal width, right? And you have three species. I think the most popular one is Iris setosa, right?
35 values which are doing with length with species 3.
Okay.
Maximum. So unique value means the maximum number of times that particular length is being
No,
repeated.
no, no,
Then
no. Unique values. If I have 54332 number, then the
yeah.
unique values are just three, right? Or four. Repeated values are not considered as unique values.
Then what is considered? Mean.
No, no, no.
Then
If I have 10 elements and
yeah.
five of these elements are repeated twice, the number of unique values are five.
Oh, achha. Frequent values. Frequent values,
Not,
right?
not the frequency thing, just the uniqueness. How many values are occurring for the first time? That is my unique value one. If one element occurs twice, the same number occurs twice, I won't consider it as a unique value. Okay? No, not clear?
Sir, I missed the last session, so can I see that recorded, or is it available recording?
It's available, right? You have the Excel sheet where all the videos are available.
Okay, sir.
You don't have access to that on the Python for Data Science NPTEL webpage.
Unique.
No? Or you can simply search my name on YouTube. It's uploaded over there. You can find it. The week 4 lecture. Okay?
Sir, your YouTube channel, sir? What is the name?
Just my name, Manav Mishra.
Okay, okay, sir.
Okay.
Okay. So now in this, how many values are there in this? Let's
4, 5, 1, 2, 9, 2, 3, 1, 4, 5, 6. One, 5, 3. Without the repeated value. So it is giving the numbers without the repeated one, right? All the values. Okay.
yes, yes, something like this. Okay. Let's delete this. Huh. So now we understand the entire data set, right? We know what exactly each data consists of. Now we want to understand what is the relationship. Before that, we are just looking at the data wrangling part. Like we want to basically remove all those that we don't need. So here we don't need the first column, right? Which is ID. We don't need that
I
because so we are removing that. How we are removing that is by simply this line. I hope you guys are clear what this command does till now. If you have
okay.
any questions, please ask. This line, any doubt? No? Okay. Uh,
I log.
so after this, this is the data that we have once we have removed the first column. Okay. And this now has 150 rows and 5 columns only. So what manipulations have I done? I have only dropped the first column because that is something unnecessary. I don't need it. Okay. Now, the next part, which is more important, is data visualization, storytelling, and experimenting with chart. We want to understand what is the relationship between each variable. Okay. What do we know about the relationship part? How? What are the tools we have studied till now? when we want to understand the relationship between two or three variables? Anyone?
So crosstab.
Core.
Crosstab is there. Yes. What does crosstab do?
Core.
It 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 doesn't give us the relationship, right? It just gives you a marginal probability kind of things. If I want to understand how well two variables are correlated, what do we do?
A
We
Pearson correlation we can find,
Yes, yes, you're correct. You can find the
Joint,
Pearson.
or
joint.
Kendall rank correlation.
Sure. So there is a command there. It's called .corr.
COR.
Yes.
Joint
So we'll,
probability two variables.
sorry.
Joint probability also two variables.
Joint probability is also a tool, but joint probability doesn't tell us a relationship. It just tells you what is the spread of each data, like how much data population is there in one particular class and how many data are there in some other class and so on, right? We'll look at that, but this is the distribution of the data. Okay, so what I've done is I've just plotted a histogram. So I want to understand out of 150 data points, how the data is distributed. So my sepal length ranges from roughly 4 till 8,
Yes.
and this is the distribution. So there are about 10 data points that have a length of 4.5, some have 7.5, and so on. Okay, so these are evenly distributed. I'm happy with the distribution. And we are not seeing like small uh, some small portion having a lot of data. This is the first check. We want to understand how each feature or each column is distributed. The sepal width is also fairly well distributed. So is the petal width, and so is the petal length. So we don't see any sort of anomaly in this data. Right? Now, chart 2, what I want to focus is how does sepal length and sepal width, what is the relationship? Okay, so you have three species: Iris setosa, Iris versicolor, and Iris virginica, right? So if I just look at, I can hear my voice. Can you please mute? Yeah. So this is how the scatter plot looks like. So if I plot sepal length versus sepal width, okay, and this is the uh, I have just color coded it. So Iris setosa is colored red, Iris versicolor is colored yellow, and Iris virginica is colored green. Okay. But there is a clear separation that is happening. Okay. So data is not mixed. Yes, Ashit.
So those each points that are there, they each represent one particular
Data.
data set that was
Yes.
inputted.
Yes.
So, but this graph doesn't seem very feasible or readable in comparison to the previous one.
Like this one.
Yes, sir.
So this is what I'm doing is, so if I have 150 data points, I'm just looking at the distribution of all the columns that I have. How well the column is looking, or how the spread is looking for each column, right?
Yes.
Now, in the sepal length versus sepal width, all I'm saying is, so for each data, I'm taking the two values. One is sepal length and one is sepal width. If I plot it as an XY plot, where X is sepal length and Y is sepal width, so each point corresponds to us. So this point corresponds to a sepal length of 5 point, let's say 6, and a sepal width of around 4.4. So this is one data point, and so on. And what I've done is, based on the class, I've just color coded it as it
Okay,
is.
sir.
Okay. I'm not saying I have done any sort of classification. I've just color coded it. Okay. We'll do the classification later. But if you can see clearly, based on sepal length and sepal width, I can draw a line over here, saying that
Yes,
whatever
sir.
falls above this line is definitely Iris setosa, and below it is rest others, right? But this is only based on these two dimensions. One is sepal length and sepal width. But we have four dimensions to look at, right? So we can't just
Yes.
make a conclusion over there. But we can see a very clean separation that is happening. That based on the sepal width, we can identify one species over the other, at least. We can't say clearly about these two, but this is a good start, right? Next, we want to understand what is the relationship between petal length and petal width. Similar stuff we did. And now here you can see a very clean separation, right? Now you can draw two decision boundaries, and you can say that if it falls in the middle region, then it's definitely Iris versicolor. Others, it is Iris virginica, or it is Iris setosa, right? I've simply plotted it, nothing else. Is it clear? Any doubts?
Sir, so for these graphs, we only need to know how to use the function, and we don't need to know the function itself that is being used. Like,
No, no. You just need to know what the function does, how to use the function. Just the toolkit.
so,
That
so
should be.
not like this is a bit going out of the syllabus, but in Desmos, how we have to
Hmm.
make actual functions so that the
Hmm.
graph follows the particular x or y. So
Yes. We don't
in
know the why.
this,
That is the whole point, right? The whole point
yes,
of this classification task or the prediction task is we don't have access to the why. We don't have that function directly. And that is the whole purpose, right? Whenever we do linear regression, we are trying to learn y is equal to f of x. We are trying to learn that f, right? Sorry. Yeah, is it clear? We are trying to learn this function in any linear regression type of a problem. What we are actually doing is we are learning this y is equal to f of x relationship. Yes,
okay,
yes,
sir.
Dushan. Yes, Dushan, go on. You have a question? No? Okay. Okay, now we have understood two dimensions. Now let's understand how does sepal length versus petal length varies. Okay. Again, this is a scatter plot visualization, and we can see some good separation, right? So if I plot it in a 4D, in let's say in a four-dimensional space, I can somewhat make a separation on the classification problem, right? And lastly, we have sepal sepal width versus petal width, and here also this is how the spread looks like. Okay, I'm just simply plotting the data. I'll share this code. You can see how this plotting is done. Okay. Now, finally, we are looking at the correlation heat map, and this is what the correlation heat map tells us. Everything, right? So this is the Pearson coefficient that we are looking at. The diagonal elements is always supposed to be one, right? Because they are the exact same elements. Here, what do we observe? We know that sepal length has a very strong correlation with sepal with petal length and petal width. Okay, this is something that we can identify from this Pearson coefficient, right? What else can we gather from this data? Anything else?
Symmetric.
From here, can we understand which flower we are talking about here? Three flowers are there. So,
It's
No,
symmetric
no.
in
From
nature.
this,
Symmetric in nature.
this is always has to be symmetric, right? Because you have the rows and columns are exactly same. So it always has to be symmetric. That is true. Yes. No, we can't identify the flowers in this the species, but what we can understand is how does the correlation looks like.
If it is
Yes.
positive, it is highly correlated, and if it is negative, it is the correlation is less.
No, no, no. If it is negative, they are negatively correlated.
Negative
If it is
correlated, and positive,
yes,
it's positive correlation.
yes. Zero means that there is no correlation. Okay.
acha, if it is positively correlated means if one is increasing, the other is also increasing.
Yes,
And
yes.
if it is negatively correlated means if one is decreasing, the other is increasing or decreasing?
Increase.
Increasing. So
Opposite.
one is decreasing, then the other is increasing. That is
Yes,
negatively correlated, right?
yes,
Yeah.
yes,
Thank
yes, yes. More questions?
Car and age and example.
Sorry.
Car data set. In car age and example. Negative
Your voice
correlation.
is breaking. Sorry. Voice is breaking. Can you repeat?
Negative correlation car data set age and price exp. Negative correlation.
I'm not sure I understand what you're saying. Can you repeat? I'm not able to hear you very clearly.
The example for negative correlation in car data set in the
Mm-hmm.
age and price.
Okay, okay. True,
That
true. Okay, you are giving an example of a negative correlation, right?
yes, yes, sir. Yes,
Okay.
yes.
Okay. Okay, now we know exactly how the data set looks like. We know what the correlation looks like for each feature. Now we know we can do all this feature engineering and data preprocessing, right? Okay. Now we are first trying to do a categorical encoding. Okay. So in our in, we don't sorry. Okay. We are trying to encode the species column to some kind of a numerical label. Okay. So if I run this code, this is how the encoding looks like. So iris setosa is 0, iris versicolor is 1, and iris virginica is 2. Voice is breaking. Can you guys hear me clearly?
Yes, now we
Sir.
can.
Now okay, sir. Continue.
Ah, okay, 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 okay. Yes, yes. Questions? Dushyant, question? No? Okay. So here, this is simple encoding that we have done. If it is 0, it means iris setosa. If it is 1, it means iris versicolor. And if it is 2, it means iris virginica. So this is something that we can do, right? We are just simply putting a label to it. Okay. So this is simply what we have done. If it is 0, it is this species. If it is 1, it is this species. And if it is 2, it is this species. Notice we cannot do the exact same thing. We have to do the get dummy step. If any of the data in the X in any of the column was a categorical data set, then we have to do that get dummies part to get a one hot encoding. Okay. You guys understand what is one hot encoding, right?
So could you explain that in
Yes, if
simple?
better if you can explain.
Okay. So let's say you in your so you understand what is X and what is Y, right? In your classification problem. Do you understand?
Yes.
Yes, sir.
So X is basically all the set of features, right? And Y is your prediction labels, right? What I'm saying is in X, if any column is of categorical data, then we require one hot encoding. One hot encoding. Okay. Let me see how to write this better. Maybe like this. Okay. Now, what is one hot encoding, right? So let's say if I have a categorical data which has 3 categories. Okay. Let's say it has 3 categories called lemon, orange, and watermelon. And let's say one more called kiwi. Okay. Now, one simple way to understand the relationship between them is I can simply convert to numbers, right? Like we say 0, 1, 2, 3, right? Wherein we say that 0 equals to lemons, 1 equals to orange, 2 equals watermelon, 3 equals kiwi. Okay, this is something that we can do simply, but this is not a good idea. Why? Anyone?
If there's many categorical data, then it will go to 0 to 100.
That is fine. That is still okay. Let's say if I have infinite compute capability. Okay, let's say compute is not a problem for me. Now,
Sir,
what is
if
the
the
problem in here?
sir, if the magnitude is higher, it will get sort of biased towards that.
Okay, okay. Any Anyone wants to add more to it? You go in the right direction.
So like we have to manually put in that much data, like that's why.
No, no, you can just put a function, right? You can say that
Yes, sure.
whatever is there, you just make it zero. You just put a label to it. But this type of labeling is incorrect, and there is a very good reason for it.
Hello, did you hear me?
Yes, yes, I can hear you. I can hear you.
Hello.
Or it is not in the sequence or something.
Is it
What do
like
you mean by
data?
that?
So
Go on.
data type, is it converting object to?
Int. Yeah, I'm doing that. I'm converting an object to an int data type. But yes, that's what I'm doing. But I'm saying that this is not a very good thing to do.
This
Hello.
kiwi will be taken as higher
Or
value.
it converting the categorical data into ordering
Numbers.
form.
So this is an ordinal number. Okay, so this is a categorical data. Here, this is something called as ordinal. When I say ordinal, it means a simple number, right? And the issue with ordinals is that ordinals have some sort of ranking, right? Do you understand what do we mean by ordinals has ranking? It means I can say that 3 is greater than 2. This is a
Great.
well-known fact. Okay. Or I can say that, let's say, 1 is greater than 0. This is a well-known fact. Okay. But this doesn't necessarily translate to the fact that your kiwi is uh, greater than, say, watermelon, right? This is not necessarily true, right? Or let's say your orange is greater than lemon. This relationship is not necessarily true. Okay. But if we are if we are forcefully converting a categorical data into an ordinal data, we are inherently introducing some sort of ranking into it. Okay. And that ranking means that we are saying that 3 is better than 2. Okay. And your model will try to treat it as a number, and higher number is better for the model. Okay. Something like that. So if whatever fruit I give the number 3, I am creating some sort of a bias towards it to prefer that kind of fruit. So it depends all on the numbering, on how well the numbering is done. So that's why while it is being done, but this is usually not desirable because of this kind of an ordering issue. Okay. Are you guys clear?
Yes, sir.
Yes, yes,
So
sir.
Yes,
what
sir.
is the solution? What is the solution? So you guys give me 1 minute. I'll be back. Meanwhile, I'll give you some time to think of a solution. You can discuss with each other. Give me 1 minute. Hello, hi. So any idea what is the fix to
Uh,
this?
Excuse me, sir.
Yes.
So, so like I'm not sure, but like how in some applications like YouTube, you can press 1 to 9 as one
Mm-hmm.
button, and then that will lead to like in that duration of the video, it will read to one specific point. Same
Yes.
way in hotkeys, like not
Hmm.
hotkeys, one hot encoding, you can
Hmm.
assign one particular button that particular
Okay.
data set, and then when you press that, it will show
Okay.
directly that.
Okay. Good. Good. What is that button now?
That
You're in
button
the right
is
direction. How
uh,
do I represent that button? More importantly, how do I feed it into my Python code? This kind of button.
uh, that is in your keyboard. We can assign anything that, but we need to create that function, I think, sir.
Okay. Okay. Anyone wants to add more to it? You are almost in the right direction. Just I need that representation. That representation is precisely what we call as one hot encoding. Okay. This is like your power dial kind of a thing, right? But we want to basically represent it in a better way. How do I do that? Anyone else? No? 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 So the fix is what we call as one hot encoding. Uh, how does one hot encoding work? All I'm saying is I can represent. Sorry. Are you guys still with me? Can you guys hear me? Hello?
Yes, sir. Yes, sir.
Yes, sir,
Continue.
we
Okay.
can hear you.
Okay.
Yes, sir.
Okay. So we are saying that let's say we have the first element as lemon. Instead of representing it as a single number called 0, I'll represent it as 100, something like this. And my second element called orange, I'll represent it as 0100. Third element, which is watermelon,
Identity matrix.
something like that. This is called as a one hot encoding vector. Okay, this is a single vector that I'm creating. Okay, so if I want kiwi, I'll represent it as 0001. So this means I'm talking about kiwi. This means I'm talking about watermelon. This vector means I'm talking about orange, and this vector means I'm talking about lemon. Okay, this is what we call as one hot encoding. Yes.
So like identity function, basically, like how in identity function we have
Something
matrix,
similar. It's
matrix.
not.
Huh.
You can think of it as a matrix, but each element is a
So we
vector.
are taking
Okay,
the
this is a
elements
vector.
in this list, number of elements as 4 because the total number of
Yes,
elements
yes.
are 4,
You have four
right?
categories. You have four categories. Yes,
Categories. Yes.
yes, yes.
And sir, if we put more like under kiwi only, if you put comma 0 after 1, will it show an error?
Where, where? Here,
So like, yeah,
here.
yes, sir.
This will be this basically. You're talking about the Python part. I'm just talking about the logic part. Here, this
Okay,
will show an error because you have only four categories, right? You are introducing a fifth category. This means that you have five categories.
okay, sir.
Okay, so
All categories
whatever is
equal categories.
yes, yes, the length of the vector is equal to the number of categories that are available to you. Okay, so this is something that you have seen in your get dummies function also, right? So let me explain even better. So if you have a feature vector x, which is let's say car type. Okay, let's say your car type, and you had let's say two data. One is manual and one is automatic. Okay, now I want to represent it in something like a one hot encoding vector. So this is a single column. Okay, notice that this is a single column that you had for car type. Now when I use the get dummies function, what this get dummies does is it creates a dummy class. It creates a dummy column altogether. Okay, so instead of car type, you now have two functions called car type 0 and car type 1. Okay, and what does this car type values contain? It contains values like 10 if it is manual, or it contains 0 comma 1 if it is automatic, right? And when I say 10, I mean that car type 0 will have the value of 1, car type 1 will have the value of 0. Okay, I'm not saying it will contain a list. I'm saying that each of these columns will contain an integer value. So I'm basically extending the number of columns so that I can, instead of having a categorical data, I can introduce a vector in it. And I don't mean to say that I include it in the form of a list. I'm saying that each category will be expanded as a new column and it will only be filled with values like 0 and 1. That's it. Okay, is this clear?
Sir, so just 0 and 1 is enough for like
Yes.
expanding the whole. Uh,
Yes.
okay, sir.
Yes, this is a
And
binary representation.
what if we just by mistakenly put 0 comma 2?
No, then it's not a one-hot encoding. One-hot
Okay.
encoding is a binary representation, and it is simply saying that the category that you have selected is one, rest everything else is zero. That's it.
It is
Okay,
only
sir.
binary means 0 and 1 only, na, sir?
Yes, this is what we call as one-hot encoding. So one of the key is hot. When I say one, it means that this particular element is hot, rest everything is cold. So in this vector, we are saying that this is a one-hot encoded. So one of the value is hot, rest others are cold. Okay, you think of it in that way. Okay, like hot and cold kind of a uh, understanding, right? Is it clear? Any doubts with one-hot encoding and why it is necessary?
Yes, yes.
Okay. Can I move ahead? If you have any more questions, please stop me in between. Okay. So this is precisely
Sir,
what we have done in. Yes.
sir, is it applicable only in case when all the categories, all the elements are of categorical nature?
Yes. Whenever you have a element which is of categorical nature, which is non-numerical, okay,
Yeah.
then we need this one-hot encoding to basically to feed it into your Python codes, right? You need numbers to feed into your Python code, right? And not
Okay.
some string.
Fine.
Okay.
Thank you.
Okay, great. Now we are defining the x and y, which is the data scaling part. Okay. So what is x for us? X is this value, right? So if I say x of 0, I'm just taking one element. Okay. So if I just look at one of the element, it says that it's a single vector for me, right? And similarly, you have y dot I log of 0. It's a single number, right? It says iris setosa directly for me. Okay. All good. So I've
So
just
how is
separated.
okay.
Go
Sir,
on.
how is it that you just put a column equals to species and then axis one, and then it gave so many results?
Oh, so what I've done is I'm just dropping. What I've done is first I'll print the data, right? So what is data? Data is this
Yes.
whole data frame, pandas data frame. Okay.
Yes, sir.
So I'm saying that I'm dropping the species column. So the whole species column I have just dropped. Rest everything else is what I call as X. That's it.
Yes, sir.
Okay. And I'm saying Y is simply the last column, data species, which I've dropped. Okay. I've just separated this part to be X and only this part to be Y. That's it. Okay.
And sir, so then individually we can go and change and like however we want
Change what?
separately. Like so under CPL length CM, we
Hmm.
can change like one we don't want it to be 4.9, we want it to be something else, so that we
Hmm.
can individually change later
You can
on. Like
change. You can change individually. You can change. But why do you want to change it? This is the data that you have collected. After
yes,
You can change. You can change. You can manipulate the data as you wish. Of course.
okay, sir.
Okay. So you have x and y. The purpose of x and y is given this x, determine what is y. Okay, this is the problem statement for you. Given sepal length, sepal width, petal length, and petal width, what should the y be? Okay, and this is the corresponding label for it. Okay, when I'm training something, I have the x and I have the y. I'm trying to understand what is the relationship between the data, so that later when I have unseen data, I'll be able to predict. Okay, so what is the next step that we can do once I have with the x and y? Anyone? The next logical step.
We will be plotting it.
We plotted,
or
no? We
grouping
have
it?
plotted everything. Grouping as in?
We will be doing the prediction
But
using
prediction before
the
that, something
while
very important. That is true, but something even more important
uh,
before going for the prediction.
Train test.
Training.
Wait.
Yes, yes.
training.
We
Training.
want to basic,
Training,
we
yeah.
want to split the data into training data
Train it.
and
Yeah.
testing data. Okay. This is
Mhm.
exactly what we do. We are splitting the data into train and test, and the train test split is uh, the test size is zero point 0.3. What do I mean by test sizes? Test size is zero point 0.3. Anyone?
So training will be 70% and testing will be 30%.
Yes, correct. So this is how we have split the data, and then the distribution of the data is as such. So for the training Y, this is how the value counts look like. So the value count of 0 will have 33 elements. This has 35 elements, and this has 37 elements. So they are fairly well distributed. Okay, we have enough representation for each species. Okay. Now this is a function to implement the ML model implementation for logistic regression. This function will take your X train, X test, Y train, Y test. It will fit the model, make prediction on the train model. We'll print the, we'll see what the score is, plot the ROC AUC curve, print the confusion matrix, print classification report, and so on. Something complicated it does, but this is the whole function. We are doing model.fit.
One question.
Yes.
One question. That is, while we are training, what we are actually doing is we're giving the X values and the contemporary Y values to it.
Yes. Yes.
That's is what you're doing, right?
Yes. This is what it is doing. Model.fit X train, comma Y train. Yeah. Okay. And then once you have trained everything, okay, this is what your prediction should look like. And this is what your prediction should look like on the test data. And then we are looking at the confusion matrix and stuff like that.
Sir, could you please explain this confusion matrix? Like what?
Yes, we'll discuss what is confusion matrix in detail as we go down. Okay. Let me see. Can I run this? Okay. I haven't run a lot of stuff before, right? Let's start from here. We did the categorical. We know one hot. We did the data scaling. We defined the X and Y. We did the train test. This we have done. Let's run this. Okay. And finally, we create a score data frame. We'll discuss those parts in detail. Okay. So very simple. You have sklearn, logistic regression, fit intercept is true, max iteration is 10,000. Okay. Model is trained and predicted in the evaluate model. Okay. This is clear. This is similar to what you did in the regression part. Okay. No. So I'll just run this. I'll run this, and this is how the confusion matrix looks like. So you had a question, what is the confusion matrix, right? So this is what the confusion matrix looks like. What it tells you is this is the true label and this is the predicted label. Okay, so how many misclassifications are happening or how many correct classifications are happening? It is a representation. Okay.
Okay, sir.
So when what I'm saying is, if you have, let's say, uh, you have three classes, right? You have Iris setosa, you have Iris something, and you have Iris virginica. So if the true label is Iris virginica and the predicted label is also Iris virginica, this counter gets 1. If not, this gets 1. If the true is Iris setosa, but it gets classified as Iris virginica, so then this will become 1. So this is just counting how many data are correctly classified and how many of them are incorrectly classified. That's it. So here you can see there are two data which have, what do you call this? This is called as false positive, right? Or false negative. What do you call this? So this is the true data, but this misclassified it into something else. So this is a false negative, right? And this is a true positive. Anyone can explain to me the difference? What do we mean by false positive? What do we mean by true negative? Sorry, true positive, true negative, false positive, false negative. No?
True, true negative and true positive when it predicts the result correctly.
True positive means the prediction is true and the true label is true. So it is true
Yes.
positive, which is good. False negative is good. The prediction is false and the actual value is also false. It is false negative. The issue is if it is true negative and if it is false positive. What do you mean by false positive?
It
If
is
something is
false.
negative, but it predicts it as positive. So it is called as false positive. If the prediction is positive, but the true value is negative. Okay.
Yes.
And similarly, negative is if the prediction is positive, sorry, if the prediction is negative, but the true value is positive. Okay.
Can you repeat slowly, sir?
Okay. So if I have only two elements, let me try this. Okay. In confusion matrix. Yes, Praveen.
Yes, sir. I have a small question.
Yes.
In
Go
the
on.
final examination, what will be the total number of questions and what will be the total time for the questions we answer?
Total number of questions I'm not aware, but I think it will be a 2 hour exam.
The total time is 2 hours.
I'm not sure. Yeah, something about that. Yes, yes.
Total time for the exam will be
1 or 2 hour, depending on the course, honestly.
okay.
It will be written in your admit card. You just have to wait for 1 more week. Everything will be shared with you.
So in the admit card, all the details will be there.
Yes, yes.
Thank you.
Yes. Yes, Praveen. Yeah, I think Harisha Napa has correctly uh, described the difference, but I'll just write it here as well. Okay. So if I have only two classes, okay, I have two classes, apples and oranges, very simply put. So you have something called as true positive, you have true negative, and then you have false positive, and you have false negative. Okay. So this row here is what we'll call as prediction, predicted, and this row is what we'll call as like these columns is what we'll call as true value. Okay. This is how it should look like. Is this clear? Do I have to explain this?
Sir, the diagonal
Can
elements
anyone explain?
must be true. Sir, the diagonal elements
Yes.
must be true positive and true negative, right?
Yes. True
Negative
positive
is in
and
the
false negative are good for us. This and this are good for us. We want to minimize this and this numbers. That's what I'm trying to say. These are called as the misclassifications. Okay. Anyone has any doubts? I'm just trying to go very slow here. If I have only two classifiers, or let's say I have only two classes, okay. So if I let's say that write it even better. If let's say this is class 0 and this is class 1. Similarly, this is class 0 and this is class 1. Okay. So if the actual thing is class 0 and you have correctly predicted it as class 0, then it's a true positive data. If the actual class is 1 and you have predicted it as class 1, then it is false negative, which is good for you. But if the actual class is, say, 0, but you have incorrectly predicted it as 1, then it is called as true negative. Okay. So it should have been positive, but you have predicted it as negative. Similarly, if the true value is false, sorry, if the true value is 1 and your prediction is 0, then it is called as a false positive. Yes.
Yes, so there in that matrix, 0, 0, and
Hmm.
the digits corresponding to 0, 0, and 1, 1, they are completely true and false, right?
Sorry, true and
So,
false. What?
like you have stated,
Ah,
false negative and
I would like to
true
ask a
positive.
question. The diagonal elements must be true positive and true negative, right?
Yes, sir, that's what.
okay. Okay. Now is this better?
Yes, sir. Yes, sir. Now clear, sir.
Yes, sir. Yes, yes.
Okay. Okay. Sorry. Yeah. Yeah. Please go on.
Yes, so sir, the diagonal elements, are they the extreme ends, like the true and false itself?
So diagonal elements are what we want, right? If the actual value is 0, we want it to
Yes.
predict it as 0. So any data that goes here and here is good for us.
Okay.
This is not a misclassification. This is the correct classification. You can think of it this way.
So, but what if like we put, what do you say, we put data such that it won't be almost always the zero, it won't be always the true statement or the false statement. So, can it be in the middle?
No, no, you are classifying as only two variables, right? So let's say you
Yes,
have only two classes. Let's say you have cats and dogs. So it is either
yes.
cats or dogs. What is something called as in between?
So like, there is amalgamation of cats and dogs also. No?
No, no,
That is
no,
not considered.
no, no. Your model will predict either cat or dog. Nothing in
Okay,
between.
fine,
Okay.
sir.
So in here, so now can you explain it to me what this 3 by 3 matrix tells us? Anyone? Hello. I want you to explain to me what this 3 by 3 matrix tells us.
So when it is positive and positive,
Hmm?
like in 33 case, both side is
Hmm?
positive, then
Hmm?
it is truly positive, right?
All these are
TP,
yes, yes, yes.
TP. And when it is negative and negative, like 36, then which case is this? Falsely negative? Falsely negative?
Okay, okay. So whatever I've talked earlier, it was only for a two-class classifier. Okay. Now we
Yeah.
have three classes. One is Iris setosa, we have something else, and we have Iris virginica, right? So what is class 0 for us in here? Here we don't have two classes. Here let me correct it. Here we have three classes. 0, 1, 2. Okay. So now you don't call it as true TPT and all those stuff. We'll let's say ignore this for now. But this is what it looks like for us now. Okay. This is how the data is being filled. And we know that what is 0? 0 for us is Iris setosa.
Yes.
Yeah.
Mm.
And we have 1 as something else. What is 1? I forget the name.
Setosa virginica.
Something was there, right?
Sir, this is more to
Iris
binary
versicolor.
classification, right?
Versicolor.
This is multi-class classification now. This is not my.
Yes, sir. Multi-class classification. So the order
Yes.
is 3 by
This is
n by
multi-class.
n matrix.
Yes. Yes. You're correct. Yes. And finally, you have what is this? You have
Virginica.
virginica, right? Huh. Now, can you explain it to me what is happening? So this means this is 0. Uh, the true value is iris setosa, and it has been correctly classified as iris setosa, and this is what is being filled. If it is iris versicolor and it is correctly classified as iris versicolor, this 33 elements were true as iris versicolor and were correctly classified as iris versicolor, and 33 were truly classified as iris virginica, and the label was also iris virginica. But here, what we see is one of them was misclassified as iris versicolor, wherein it should have been classified as iris virginica. Okay, so this number is 1. This is one misclassification, and this is 2 misclassification. What it tells me is that the true value should have been iris virginica, sorry, iris versicolor, but it got classified as iris virginica. So these are the stuff which we want to minimize. The lower it is, the better your algorithm is. This is a check for us. Okay, so this is on the training data set, and the whole this thing is on the test data set.
This
This is the test
36 is
confusion
both
matrix.
negative. So what is that actually?
No. Don't look at positive, negative. Don't look at the positive, negative for now. Ignore this, please.
Yeah, this
Positive, negative.
label
Think
is
of it.
confusing.
Ignore this positive, negative. This is something because your confusion matrix is by default designed for a 2 by 2 matrix. Okay. So I am telling you, think of it in this manner. Okay. This
Yeah.
is how it looks like. Ignore positive, negative. Now does it make sense?
Yes, sir. Yeah.
Yes, sir.
Okay. Okay. Now, what can we infer from this? Any idea on what can we infer from this?
So how we are
90%
So let's say
differentiating the versicolor, Sisota and Virginica by the color.
how you no,
Class
you have this 4 data, right? You have this 4 classes: sepal, sepal length, sepal width, petal length, petal width. Based on that, you are predicting if it is iris setosa, iris virginica, and so on.
Yeah, this 36 means the number of data that has been seen, or number of flowers that has been seen, or what is this 36?
36 means 36 elements, correct labels were iris setosa, and they were classified correctly as iris setosa.
Each column you
Because
can
others are
consider
zero.
for one flower.
Yes, each row and each column
One
corresponds
class.
to one class. Yes,
One class.
and the rows and
So
columns are
in
exactly the same.
33 case,
Almost
there was
third
2
classification.
There are 2
in the
misclassifications.
33 one, there was 2
Yes,
misrepresented, identified, and others are okay, right?
yes,
Oh, one again identified. That is one is
yes,
there. It
yes,
is column
yes,
in column. Okay.
yes,
And
yes,
in the Virginica case, also the same. Like one is
yes,
identified, and the two one is also misidentified. Another is there.
yes,
Okay.
yes. Go on. Yes,
The total number of rows in the data set is 108.
150, 70% of 150.
Oh, 70% of 150.
Yes. So if you sum all of this stuff, then it should be 70% of 150, which is how much? 105, right? So if you add all this up, add all these
Yes, sir.
together, it
Yes, sir.
should
Correct.
sum up to 105. Okay. Now the question is, what do we understand from this? So if I want to give a report to any company saying that, okay, I analyze all this data for you, I have this. Now I need some raw numbers, right? I want to give a report saying how good my model is. So what are the metrics that I can use? This is a complete picture. Now can I extract some meaning out of it?
The root mean
Third
square,
classification.
those metrics you can use.
What will you do?
A root mean square matrix, like how the model is accurate to check.
That is correct. You can do mean squared, root mean squared, and stuff like that. But there are certain cases where a false positive is very harmful, but a true negative, a false negative is not very harmful, but false positive is extremely harmful. I'll give an example. Let's say you have designed a model to predict whether a patient has a cancer or not. Okay. So if let's say a patient has cancer, but you have incorrectly classified saying that the patient doesn't have cancer, then that is uh, a very wrong thing to do. Okay, this is a very critical thing. But on the other hand, if a patient doesn't have cancer and you're predicting that he has cancer, there might be some stress to it, but at least uh, on later tests, the patient can get clarity that okay, he or she doesn't have cancer. But the uh, false positive part or the sorry, the false negative part is very harmful in such cases. So I want to be very clear in discriminating the false positive and the false negative. Yes, Ashit.
So can we make the AI model through multiple data set inputs able to predict how much time a patient has before their cancer
You
is?
can you can do that. You can do that. Uh, Provided you have sufficient data of all the cancer patients. Okay.
Okay, sir.
So then yes. But you understood the criticality of the scenario, right? In some
Yes,
cases,
sir.
a false positive is somewhat better, but a false negative is very harmful to a patient. Okay.
Sir,
So
and
I
how
want.
do we
Uh-huh.
Yes. So how do we make sure that the AI itself won't uh, understand that this particular data that has been put onto it can be used against a potential user only?
Like, can you give an example?
So a bit complicated, but it's like how there is that threat, of AI almost taking over us. So that prevention, how do that prevention we take care of?
Uh, how do you prevent what? Like AI manipulating some data for you,
Yes, sir.
is it? So this is a post-training thing, right? You have trained your AI, you have trained your logistical regression. Okay. So now you're testing how good your AI model perform. This is something that you are doing.
Okay, sir.
Okay. Now, in now here, hello, can you please mute? Hello.
Yes, sir, we can hear you.
Uh, can you guys please mute? Okay. Hmm. So now, question is, we know this analysis. This is a post-training analysis. We have done the model.fit. This is the trained data. This is the test data. This is what we have. Now the question is, I want to report something. So this is how the report looks like. So do you know something called as accuracy and precision? Anyone has any idea on what is precision?
Precision is
So
total
like
positive divided by the total diagonal
yes.
elements.
Total positive divided by the diagonal
Total
elements.
positive divided by diagonal elements.
Can you put it
Total
in words?
total.
True
That
positive,
is the correct.
true positive
With
upon true
how much
positive
of this
plus
model can
false
predict the
positive.
positive cases?
Or is there a better wording for it? What do you mean by precision?
So
How
like
precise?
considering the two extreme ends, what is the best possible scenario like that?
But there is a very strict definition. When I say accuracy, what do I mean by accuracy and what is meant by precision? Okay, it's a very fundamental question. Accuracy versus precision. When what is what?
Uh, Data points
Accuracy is like model's
predicted
ability to predict the correct
correctly upon
instances
total data
in
points.
among all the possibilities.
But what? What in that?
True positives. Accuracy is nothing but how much it can predict the true positive cases among all the instances.
Okay.
The model
And
can
what is
predict.
precision? Okay, good. And what is precision? True positive is good. All those true positives and false negatives are good. Uh, but this is true positive, right? Model correctly predicts the positive class. In the above example, 10 people have tumor are correctly predicted by the user, by the model. Uh, Sorry. Uh, yeah. So this is where is precision? Precision is TP by TP plus FP. Okay. So basically saying out of all the positive data, how many of them were correctly predicted as positive? Okay. That is what we meant by precision. And what is recall? Out of all the positive and negative data, how many of them were correctly predicted as positive? Uh, is this definition clear? Can anyone maybe explain it in a very easier manner? Hello.
So like maybe after multiple stages of ac- uh, correcting the accuracy of the uh, output itself, we get the final uh, uh, best result that gets outputted, something like that.
So this is precision. Out of all the positive predicted, what percent is truly positive?
Yes, sir.
Okay. So you have predicted out of total, you have, let's say, your model predicted out of 150, the model predicted 105 data as positive. Okay. Now, out of those positive data, how many of them are actually positive? This is what precision tells you. Okay.
Yes, sir.
And recall tells you out of the overall positive, what percentage are predicted as positive. Matlab, let's say the true number of positives in the entire data is actually 130. And out of that, how many your model has predicted as positive is what you call as recall.
Okay, sir.
Okay. So this is a simple definition of what precision and what recall is. You can calculate the precision and recall, and this gives you a raw number. Okay. What this number gives you, it gives you your precision for class 1 is 1. So this is Iris Satosa. Your precision is 1, recall is 1. Here your precision is 0.97. Yes, Sivanan. So here it is 0.97 because you have two misclassification. Sorry, you have one misclassification here, right? In the predicted part. Okay, recall is 0.94. And similarly, in class 2, you have this is your precision and this is your recall. Okay. Now, precision and recall helps you understand on the criticality of what you want to basically focus on. Do you want to focus more on the precision part or do you want to focus more on the recall part? Okay. Now let's say if I'm dealing on let's say some car data set, then precision is good for me. Okay. I want to know how precise my model is at predicting the data. But recall is useful for me if I'm dealing with let's say cancer data. Okay. So there a negative prediction is very, very harmful. So I want to penalize my model, saying that giving me any negative or any false negative is very, very bad for me. Okay. So if a person has cancer, but I predict it as not having cancer, it's a false negative. And that's a very critical case. So I want to reduce that. So that is where your recall comes into picture. So these two metrics, precision and recall, are important in the sense that it gives an understanding on how good your model is actually performing. Okay. Now there is something called as F1 score. Any idea what this F1 score is? Anyone? Have you heard of it before?
Is
Are
it
you
is it
getting confused?
generative? Is it generative AI?
No, 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 no. There is no generative AI here. We are not into AI at all. This is simple data science. F1 score?
So could you repeat the question?
Beta is equal.
Sorry. What we know what is precision. We know what is recall.
Yes.
Precision is out of all positive, how many are actually correctly positive, and recall is out of all the predicted data, how many are correct actually positive. Now we know in some cases we are well off, we are better off improving the recall. In some data set, we are well off improving the precision. Okay. In some cases, recall is important to us. In some cases, precision is important to us. So this is always a trade-off that is happening. In one case, you can maximize your precision, but the recall takes a hit. In some cases, you can maximize your recall, but your precision takes a hit. Because let's face it, you cannot have a perfect model. Okay, you will always have some sort of misclassification. And this is a very simple data set. You have only 150 data, and still you were able to, in a very clean data set that you saw, right? You saw those very neat separations when we plotted the sepal length versus sepal width data, right? You had very clean separation, and in that also you are having three misclassifications. So let's say if in more complicated data like the Toyota cars data set, you will have a lot of misclassifications. Okay, so your model will never always be perfect. So now the question is, you can only improvise on that, on the recall or on the precision part. So it's a trade-off that you are balancing always. Now there is something called as F1 score. So what is F1 score?
Harmonic
F1
mean.
score. F1 score is simply this formula, what you see on the screen. Okay, twice of precision into recall divided by precision plus recall. Any idea what it is?
It's a harmonic mean of this.
Uh, but what does it mean in words? So that is fine. Mathematical definition we know. What does
So,
it mean?
so then this F1 score will be like the combination of both this
Yes,
both precision and recall, and then the
yes.
best possible outcome from just those two will
Hmm.
be given for the particular
F1 score.
situation. Yes.
Yes, yes. You're correct. You're correct. So what he is trying to say is, I am always balancing the trade-off, right? So F1 score is a measure of this trade-off. How well that trade-off is well balanced, or how well we can maximize that particular trade-off. So it is taking the mean of, or rather, not the arithmetic mean, but the harmonic mean of precision and the recall. Okay. So if the F1 score is higher, that means I have done as good as it could have. Like the trade-off is very good for me. If it has lower score, that means the trade-off is not that good. It is biased in some aspect. Okay. Let's say your precision is very high, but your recall is very low, then your F1 score will be lower. If your precision and recall are sufficiently higher, your F1 score would also be higher. Okay. So a high F1 score is very, very desirable for you. Okay. Is that clear?
So what was that F beta under F1?
I think it's a weighted F1 score. So you can give some sort of a weightage, right? So
To
if
the
the recall
preferred
is
score.
twice as important,
Okay.
so like I said, if the recall is twice as important as precision, then the value of beta is 2.
Yes, sir.
If something is more important, you can give a weightage to it. Like I said, in the cancer data set, your recall is very important. Your recall is much more important than your precision, right?
So
And
what
this is
was
the
that?
data.
Yes, sir. Sorry, sir. Continue.
Oh, no, no, please go ahead, go ahead.
Which was that site which is explaining F1 and beta?
Okay, I'll just link it here. You can go visit. Okay.
Yes, sir.
Okay. So this is your test classification report. So this is on the training data set and this is on the test data set. So now, after all this thing, uh, what do we say? How well we did on the logistic regression end? Any ideas? Is it good, bad? Okay, okay.
It's the best of the two extreme ends, you could say, no?
So what we are seeing in the test cases, if you look at the test confusion matrix, you saw that there is only one misclassification out of 45. 43 were
Yes.
correctly classified and 2 were misclassified. So let's say your error is roughly around 4. So error, that is the accuracy. Okay. What is accuracy? What I'm saying? Out of 45, 2 were incorrect. So 43 out of 45 was correct. That is your accuracy, right?
Yes, sir.
And what is your precision? Your precision is about 0.93 for this class and so on. Okay. So I think it's a fairly decent thing that this model has learned. Okay. This is the overall macro that we or the overall understanding that we get through this simple data science project. Okay. Now, yeah, this is the final score. This is printing everything. And okay, I'll just walk you through what we did till now. So you guys are still with me. Okay. A very simple data science project consists of the following steps. Okay. First, you want to know the data. What we did in know the data, we printed everything. We are checking for missing data set. We are looking at the shape. We are understanding how many rows, how many columns are there. If there are any null objects, if there are any duplicate objects, we are filling all the null objects. And finally, we get an inference. We know that there are this many rows, there are no duplicate values and no null values. So this knowing the data is the first step. Second step is you want to understand the variables. When I say understand the variables, that means I want to understand how each variable behaves. Okay, what is the value each variables can take and so on. And then you can do data wrangling stuff like that. You understood the variable, you did some data wrangling, you are removing all those unnecessary parts. Then this is the most important part. You want to understand the data. You want to understand how the charts look like and we did a lot of experimentation. We saw that the data is fairly well distributed. We understood the relationship between any two features that we had. Okay, and so on. So this is the data visualization part. So the reason we do data visualization is we want to identify if a particular feature is good or not good. Okay, so let's say if you have hundreds of features, and if you don't want to deal with all those features, so this visualization helps in identifying all those features which are good for us. Okay, visualization is often a great tool, and then we do all those data feature engineering and data processing, like the categorical encoding that we did, the one hot encoding stuff like that, which we discussed well in detail today, right? This is the step, and yes, go on.
Sir, so then this essentially can be like in future can be
Uh,
inputted in various different aspects of let's say recruitment or like
mhm.
selection process. It will make
Mhm.
that very much smoother also, no?
Selection now of what? Candidates.
Yes, sir.
Yes, yes, of course. So let's say each candidate has a set of features, right? You have, let's say, you gave some exam, you have some exam score, you have your
Yes,
CV
sir.
score, you have your, let's say, 10th and 12th grade scores. So these are all set of data for each candidate, and then the classes are select or not select. Yes, most companies do that.
So, sir, they already started doing, or it's still a very
No,
base
no,
model?
no. This data science has been there for quite some time. It's just
Okay.
understanding the data. There is no ML involved till now, right? You have to understand, right?
Okay, sir.
It's just the data. So each company has a certain threshold. How do they decide this threshold? So this is what logistic regression does for you. They draw a
Yes.
threshold. If you're above the threshold, you are in this particular class. If you're below the threshold, you are in this particular class,
So,
right?
so have they already started this
Yes,
particular
yes.
selection process in like recruitment?
It depends which company you're talking about.
Because, sir,
But if
like, yeah, continue, sir.
so most companies do this. If you have, let's say, 10,000 applicants for a job that has only 10 openings, so you can't
Yes.
necessarily call for interview to each candidate, right? So this data helps you filter out a lot of candidates, and you can only, let's say, call to interview those candidates which pass those certain threshold. So yes, this is what uh, happens a lot in college admissions, in company recruitment, and stuff like that. I'm not sure if all companies do that, but those companies that are dealing with a lot of data, they are doing these kind of stuff.
Okay, sir.
This also helps in decision making, right? So let's say if you have, let's say, a company like Flipkart, okay, they introduce a new product and they want to understand how well that product is doing. Okay, so they can pull out the numbers saying what customer bought, which geographical region the customer bought that particular product. They can draw this data, okay, and then using those data, they can make an estimate on how good or how hit or how miss that particular product is. And based on the data, they can introduce new projects or they can remove that product altogether.
Yes, sir.
So this data helps you get an overall idea, right?
Yes, sir.
Yeah. Uh, so lastly is the ML model implementation. Here we are simply looking at logistic regression. Okay, logistic regression. What it is doing is you are given a x value, which is the set of features, and y is the prediction. You do a fit, a model.fit, all the code over here. And then finally, once the data fitting is done, your logistic regression is done, you're evaluating the model. How you're evaluating the model? You use something called as a confusion matrix. We discussed in detail what confusion matrix looks like. You Anything that goes in the diagonal is good. Anything that is off the diagonal is very bad for us, right? And after that, we also looked at some performance metrics like precision, recall, F1 score, and stuff like that. I'm not sure if F1 score, precision, and recall are a part of your syllabus. Were they covered in the video lectures? I'm not sure. Can anyone tell me if you have gone through the codes that they have provided?
So
No?
one question I have.
Yeah.
So for the cards model, you said that false positive is very important. And for cancer data, you said that false negative is important.
Yes,
So
false negative
I
is
just,
important.
yeah, because if someone doesn't have cancer, it will say it has cancer, right?
No, that is still okay. If somebody doesn't have cancer and I say you have cancer, you can do some other test and you can maybe
Okay.
after 2 or 3 tests you can determine that. Okay.
Yeah.
At least if I tell you you have cancer, at least you will go for further process and
Understood.
get it verified. Okay. But
Yeah.
if I
But
say
you
if
don't
you have
have
cancer,
cancer.
that is very bad. Okay.
Don't have cancer, and you have cancer, and if they say you don't
Uh,
have cancer, that is false negative. Yeah.
yes.
That is okay. For the cars model, why false positive is more important? If you can
Not
tell.
false positive. It is important. Basically, the cars model doesn't make a differentiation between false positive and false negative. Either of them is bad for me, right?
Right.
It is not sensitive in that sense.
Okay.
Yeah.
So in the let's just consider cars model, we have to put a weightage to our particular what do you say, uh,
Hmm.
that F beta that was there. In that
Uh,
we have to put weightage to even F1. So that
uh,
will be useful for the cars model because cars we have to even look for the resources and all the other factors,
sure,
right?
sure,
So
sure.
that
So all this weightage part is something that a domain expert can tell you. Okay. So they
okay,
can
sir.
tell you what is more important to you, what is less important to you. So you require some kind of a domain expert. So imagine if someone who is a researcher or let's say a consultant and they have access to this data and they are a domain expert, then this kind of data helps them in understanding how the data looks like and how they can take corrective steps to improve their modeling,
So
right?
then basically this will be considered under like uh, masters and PhD level studies, right? Or will it be still
Not necessarily, not necessarily. So it depends, okay, what role you are looking at. So there is something called as a role of a data analyst. Data analyst. Have you heard of data analysts?
yes, sir.
And have you heard of data engineers?
Yes, sir.
What is the difference between a data analyst and what is the difference between a data engineer?
The person who will be on the back end and just essentially taking considering all the data that has been provided and like making applications based on what the client wants.
No, 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 no. When I say data engineering, I'm trying to engineer the data. Okay. What do I mean by engineer the data? I have access to a lot of data. How do I design data? Okay. Or let's say if I want to collect some sort of data, right? It's let's say the feature design aspect of it.
Okay, sir.
Like petal length, designing if I need petal length, if I need sepal length, who decides that? That's the role of a data engineer, right?
Yeah.
What data you need to collect, those kind of stuff. And what does the data analyst do? The data analyst does this visualization stuff. They'll plot this confusion matrix, understand this. So this not doesn't necessarily require you to have a master's or a PhD. This is very well suited for an undergrad as well.
Okay, sir.
Okay.
Yes, sir.
Yeah. Any more questions? I think that's it. I one more thing that these guys did. Maybe this is not this is beyond the scope, right? So we'll just skip this. The hyperparameter tuning cross validation part. But I hope you have a general sense, right? The course is simply a 4-week course. Okay. This gives you a basic introduction to what data science is. Okay. How you, once you have access to a data, how you can make sense of that data. That is the entire uh, motto of this course. And this is like a very introductory section, right? Now, since this is our last class, if at all you are interested in understanding what happens in the backend, like let's say I have taken this logistic regression part. Okay, this is called model.fit. So how this fit is happening, what is going behind, what is the math behind it? Okay, or let's say if you want to understand what is your k nearest neighbor classification, what is random forest, what is decision tree, okay, what is linear regression, what is happening? All this comes under the course of machine learning. Do consider checking it out on NPTEL, or if you I have some credits left. Take it in the next iteration. So you will understand the science behind what exactly is happening, how the model is performing. So all this ML model implementation comes under the uh, umbrella of the course of machine learning. Okay.
So there is a
Sir, I
separate.
want to.
Sorry.
Go on,
Sir,
please.
yeah, I'm telling you, I want to get the actual answer for the question is that the logistical regression model built between the input and output variables is checked for its prediction accuracy for the test data. What is the range accuracy of the prediction made over the test data? This is a week 4 assignment question. So I just gave it somewhere like 90 to 95, but they are saying 80 to 89. So in most cases, this is 80 to 89. So the answer is 80 to 89.
No, no, no. What is the question? Sorry, I missed your
The
question
logistic
completely.
regression model built
Uh,
between input and output variables is checked
uh,
for its prediction accuracy of the test data. What is the
yes.
accuracy in percentage of the prediction made over test data? So it can be
So
anything
give me
actually, but they have given four ranges. One is
options.
50 to 79, one is 90 to 95, one is 30 to 59, another is 80 to 89. So I gave an accuracy of 90 to 95, but the actual answer is no, sorry, I gave an accuracy of 80 to 89. Hmm.
Okay. They might have provided some data, right? It is
Yeah,
you
I gave
can't
an
say
answer of 80 to 89, and the answer is actually 90 to 95. But
okay.
usually it is like within 90. That's why I gave that answer.
No, so
But how mostly it is 90 to 95, or it can be
no,
anything,
no,
right?
no. It can be anything. It depends on what the
It can
data
be
that you have
anything.
provided with.
So why is this the answer is 80 to 89 here? This is the actual answer. Actually, I gave a wrong
So
answer
they
to
might
this.
have provided some CSV data, right, for that particular question. I think the test accuracy is for the given CSV that they had provided.
Okay. So we have to
Okay,
do
not
the
for any general.
program and you see the output and do.
Yes, 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 yes.
Okay. And another thing, another one I have. For after applying logistic regression, what is the correct observation from the resultant confusion matrix? Okay, now this
Sorry,
is they
sorry.
are saying is
Yeah.
after applying the logistic regression, what is the correct observation of the resultant confusion matrix? So
Yes.
they are saying it is true positive 29 and true negative 94. So this one is partially correct for me because I have not given
So
false
it
positive
you have
5
to
and true negative 5. So
you have
how
to
do you
look at
understand
the
it from the confusion matrix? We can understand this.
understand what true positive, true negative. Yeah, you
Yeah.
do right. So here you have right. When I say
Yeah.
all these are true positives, true negatives, false positive, false negative, you can understand everything from the confusion matrix.
Okay.
Okay. Uh,
Okay.
So one last question.
yeah.
And
So
one another question. In this linear regression model, if a linear regression model achieves zero training error, can we say
Hmm.
all the data points lie on the straight line in the feature space?
Yes.
So it should be a yes. But
Uh,
does it always lie on the same? And some points may be in a different place, right? All the points will it be on the same line, even if the all the training is correct. This training there is no training error
so that means all the points are lying on the line.
all the points will be on the line. That means
Yes, yes. That's how you get a training of zero, right?
okay. And there is one multilinear regression model on global happiness index data set.
Uh,
So they are saying what is the RMSC root
hmm.
mean square
Mean squared error.
value, or
Yes,
that will be 1.06. So if we
yes,
calculate, so it should come as 1.06, right?
yes, yes,
Okay, using that data set.
yes, yes.
In exam, how to
And
access data sets, sir, to
I
solve the
don't think you
problem?
will be asked. I don't think you will be asked to do coding in the exam.
Yeah, but they if they ask this kind of question, so we cannot answer it without doing performing it.
No,
So
no,
this kind
you
of
can't
question
answer
will
that.
not come. That means.
No, no, no.
So one last question.
Yes.
I just checked under Swayam of NPTEL courses, there are 5 machine learning courses. So any course is enough, right?
Any course is enough. Yeah,
Okay, sir. Thank you, sir.
yeah.
Sir, I will write you a
Sir,
question.
for
I'll go
data
on
sets
writing it. Others can question.
data
Okay. Go
set
on.
questions are only for knowledge purpose, sir.
Yes, yes, yes. Only for your knowledge, not in the final exam. Yes.
Sir, I have a question related to my examination. If one has missed one of the assignment, is it still eligible for the final exam or not? I
Yeah,
got the
I think
ticket and details.
you should be eligible. You if you perform well enough, I think they're taking best 3 out of 4 assignment, right? So if you missed one, then the other three marks are considered as your total marks. As long as your overall total is above a certain threshold, then it is fine. Then it is okay, right? So any more questions? I'll share this data set with you. Any more questions? I'll just stop sharing.
Sir,
So,
I'm
so,
just writing a program. You can tell me the
Sure,
output. I'm giving it in the message.
sure, sure.
so this class will be available on YouTube or something, right? After.
Yeah, yeah,
Okay,
yes.
sir. Thank you,
By
sir.
tonight only, I'll upload it on YouTube. So those guys who want to see this class, go to my YouTube. Search me on YouTube. You will find all the lectures that I have uh, taken, all these tutorial sessions that I've taken. There should be 4 videos. This is the 5th class that I'm taking, and this is the final class. Okay.
Okay, sir.
Okay. Great. So yeah, I think that brings us to end of the class. If you have any questions, I'm still waiting. Yeah, sure.
So what should be the output of this program for I equal to range len first minus one minus two. Second is
Uh-huh.
first I plus second.
So
Second
what
will
is first and what is second?
first one. The first, yeah, I'm giving the first one. First is second is length.
So could you just send the what is it, URL of your channel on
Okay.
the chat?
So go to YouTube.
Dos को DO होगा. I'm writing
Uh,
it again.
yeah, sure. So this is my URL. Just go there directly. Okay. Yeah.
Thank you, sir.
Sir,
Yes.
sir, we don't have to work with the data sets in the exams. Like we
No,
are
no,
not getting that those kind of questions.
no, no. Those won't be. It will take time for you, so they won't ask those questions in your exams.
But sir, week 3 and 4 are completely of like these questions only assignments.
Uh,
But how
but
about
that's a weekly assignment. That's a weekly assignment. You are supposed to take a week to solve those questions, right?
yeah, yeah.
In exam, you will have 1 or 2 hours, right? It won't be possible to solve those questions.
I doubt is also same.
So
So
this
in
is the
third
one.
week and fourth week assignment is mostly on data sets. So may
Okay.
how the question paper can expect, sir? Because third and fourth week
Yeah,
is
yeah. They
mostly
won't.
on data sets.
So
That
what
is
is
for
the
your
output?
understanding only.
What is the
But sir,
output?
my doubt is like it is completely based on the same topics, no? Like logistic regression, linear regression.
Yes.
Then how we are getting without the data set, how we can do?
They won't ask questions which involve data set. They'll ask questions based on the understanding of it,
Yeah.
like what you had in week 1, week 2, and week 3 without the data set. All those questions they'll ask.
Okay, so maybe like the topics what we understood from those, we get those kind of questions. Thank you.
So what is the
Yes.
output of this program? Uh, for according to me, it should be EOSDEA. But the actual answer they're giving is AEDSOE.
What is the line? Second is equal to first I plus second. What does it mean? Are you adding?
Len first minus 1. So it is taking the
Uh,
last character. Then minus 1 and minus 2. Minus 2 means it is alternate, it is taking, leaving 1. And the stopping one is minus 1. That is a bit
yes,
confusing with stop because you take it from the back side. Then minus
yes.
1 is the last character, which is starting from here.
It should not be minus one. It should be one.
It
Please
should
check.
be 1, right? And the
Yeah.
answer should be this. Just see whether I'm right. D E A.
EOS I
EOSDEA. This one is the
uh,
answer, right?
should be.
Is it right, no?
You are reading from the back, but you are skipping
Yeah.
one
Yeah.
element. Yes, yes,
This is right,
yeah,
no?
yeah.
Thank you.
Okay, okay, great.
Uh,
That brings an end to this extra class. Yes.
So it won't be like JE, right? At all.
No, 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 no. Don't worry. Don't worry.
Okay, sir.
It
Thank you.
is. It
so
will be
what
one
is
level higher
the
than what you did in the assignment. Yeah. Yes. Go on.
yeah? Was there any uh, like we can be absorbed in some kind of internship or something?
Some girl had asked this question. I'm not aware, but she
Yeah.
said that some toppers have some access to some program. I'm not aware of that, but maybe you can Google it and check it out. Okay. Okay, guys, I'll stop the recording. Thanks a lot
Yeah.
for
Sir,
attending this
uh,
class.
sorry, one last doubt, sir. Do we
Yes.
have any like previous year question papers to refer?
No, no, no. Unfortunately, no. It's an online exam and they don't release the question papers.
So the
So we
question
won't.
paper will be more based on programs, like
No,
the
man.
one I just
No,
gave.
no,
No,
no, no, no.
on concepts
Something
also.
similar. Yeah, yeah, yes. Yes.
Thank you, sir.
Okay. Thanks a lot. Thanks a lot. Thanks a lot for attending this
Thank
sessions.
you, sir.
And hopefully, we'll meet each other again if you take some later courses
Like
next
any
semester.
problem we face, we will email you.
Yeah, yeah, sure, sure. Feel free.
So your
Okay.
email
Thanks
number
a lot.
is
Uh,
we
you
can
can
give
find it
it.
in the slides. I have shared the slides, right, in the
Yeah.
Swayam portal. You can check in the slide. You have
Okay.
all the details are there. Okay.
Okay.
Okay. Thanks a
Thank
lot,
you.
guys. Bye.
Thank you.
Thank you.
See
Thank
you.
Thank you, sir.
I'll stop the recording. Thanks a lot, guys.